Welcome to topic 2, proportional relationships in tables. Our focus question for this topic, what does it mean for two quantities to have a proportional relationship? How can you tell if a table shows a proportional relationship between two quantities? So our first key concept, two quantities, x and y, have a proportional relationship if y is always a constant multiple of x. This is important, it's a constant multiple of x. A relationship is proportional if it can be described with equivalent ratios. So let's look at this picture here. We have 6 circles and 3 squares. So we can write 6 circles to 3 squares, which we know can simplify to 2 to 1. We can also look at it like this. If we were not to have these 3 here, we would have 4 squares, or excuse me, 4 circles to 2 squares, which still simplifies to 2 to 1. Or we can simplify it even further, and we can have 2 circles to 1 square, which of course is 2 to 1. So there are 2 times as many circles as squares. There is a proportional relationship between the number of circles and the number of squares. Let's look at the first example. A table can be used to show a proportional relationship between two quantities. What we always do is we try to show that y over x is the same for each row of our table. So our first row, x or y over x, is 2 over 1, which is in simplest form. Let's look at our second row. Y over x is 4 over 2, which I can simplify to 2 over 1. Our third row, y over x, is 6 over 3, which again simplifies to 2 over 1. The last row, y over x, is 8 over 4, which simplifies to 2 over 1. Because each row of y over x simplifies to the same ratio of 2 over 1, then there is a proportional relationship between the two quantities. Looking at these two tables here, I want you to determine whether each table shows a proportional relationship between x and y. Pause your video here and work on these examples. For the first table here, there is a proportional relationship. Each row, when I simplify y over x, simplifies to 3 over 1. So the first one is proportional. The second one is not. The first ratio, y over x, is 1/2. The second one, 3/7, can be simplified. The third one, 2 over 6, is 1/3, and the last one, 1 over 5, is 1/5. So they do not all simplify to the same ratio. Example 3. A company manufactures custom car paints. A manager receives orders for 25, 35, and 105 gallons of their powerful purple paint shade. The paint manager panics and says, none of the orders match our mixing chart. How can we make these orders? Provide a solution for the panicked paint man. I want you to think about this. Let's look at this. We have the number of red gallons of paint, number of gallons of blue paint. 2 here, 3 here, 4 to 6, 20 to 30, 40 to 60. We need to make orders of 25, 35, and 105 gallons of the powerful purple paint. I want you to answer this tonight. Do your best. Try and come up with a solution. Show me what work you can, and we are going to go over this one tomorrow. But I want your brains to be thinking about it tonight. For the next example, the diagram shows a series of squares drawn on graph paper. The side length and the perimeter of each square are labeled, and it's important that we know we have squares. Use the diagram to complete the table. We're going to write all of the ratios in simplest form. So if the square has a side of 1, its perimeter is 4. If it has a side of 2, its perimeter is 8. If it has a side of 3, its perimeter is 12. So, we know the side length, we need to fill in the perimeters. If the side length was 2, we can look over here and we see we had a perimeter of 8. If the side was 3, we had a perimeter of 12. If we have a perimeter of 12, our side length is going to be how much? This, if we simply look at it, 4 over 1, simplified to 4 over 1. 8 over 2, simplified to 4 over 1. 12 over 3, simplified to 4 over 1. 16 over what is going to simplify to 4 over 1? 16 divided by 4 would give me 4. For the next one, 5, the perimeter would have to be 5 times 4 is 20. And if the perimeter is 24, the side length must be 6. If I divide 24 by 4, I get 6. So if I write my ratios, the perimeter to the side length, 4 over 1. Here for the next one, 12 over 3 simplifies to 4 over 1. 16 over 4 simplifies to 4 over 1. 20 over 5 simplifies to 4 over 1. 24 over 6 simplifies to 4 over 1. Is the relationship between the perimeter and the side length of the square proportional? It certainly is. And how do we know? So let's write this up. Yes, there is a relationship. It is proportional. The ratio of the perimeter to side length is 4 to 1. Meaning, the perimeter is 4 times the length of the side. Of the square. Make sure you go back to example 3 on the previous slide and think about that one. We're going to discuss that. And then at the end of the lesson, I will see you in the next class.